Alright, so this video is going to explain how to do lesson number 3, circle terminology. This video you're going to do by yourself at home, since we're kind of strapped for some time here and it's really just a lot of definitions. So I'm going to help you along with it. If you want to fast forward or pause at any moment in time, just do so. So first things first, the opening exercise. The opening exercise, I want you to be able to tell me 3 things that you already know about a circle. So there's a couple things that you should really know. All right, so we should know that a circle has 360 degrees. You should know that a radius is the distance from center to the circle. And you should know that it has a diameter, which is 2 times the radius. Some of the terminology that we'll use in this course is going to have us going through and remembering some of this stuff. So here's some vocabulary words. We'll start with radius. This one should be straightforward because we already know it. So the radius of a circle is the distance from a center to the outside of the circle. And we could draw that by making the center of the circle and then drawing a point to the outside. That's the radius. The other thing that we should know about a radius is all radii, it's the plural of radius, are congruent. So if I was to draw another radius here, both of those radii would be the same size. The next vocabulary word is a new one, chord. Chord is a segment that has endpoints on the circle. So a radius would not be considered a chord because one of the endpoints is the center of the circle. So if I was to make the center here and then draw a segment that has endpoints on the circle, that would be considered a chord. There's a lot of things about chords that we know. One of them is the closer the chord is to center, the longer the chord will be. So for example, if I could just grab a different color pen here, let's see. If I was to draw this red chord, notice that red chord is significantly longer than the blue one. And if I was to draw this green chord, that one would be significantly shorter than the blue one. So the further you are away from center, the longer your chord is going to be. And then the next vocabulary word you know already, but let's define it now using some good vocabulary. So the diameter of a circle is a chord that passes through the center. And the diameter will also be the longest chord of a circle. So let's draw our diameter. So to draw a diameter, we need to make sure that it does in fact pass through the center. So notice it's a chord because the endpoints are on the circle, but it also passes through the center of the circle. So using these 3 vocabulary words, we can define some things about radii, chords, and diameters. So let's look at this next problem. So exercise 1 says, identify each segment in the circle below as a radius, a chord, or a diameter. So there's a lot of different segments that we have here. So I know that AD is a radius. I know AB is a radius. I know AC is a radius. And I know all of those radiuses are congruent to each other. They're all the same length. I also know that BD is a chord. And there's only one diameter here, CD. which is also a chord, but it's a chord diameter. Then it says explain why ABD must be isosceles. I know ABD is isosceles because AD is congruent to AB because they are the radii of the circle. That second question, although you don't think of it that way, it is actually a proof, right? We have a triangle, two congruent sides. We know that two congruent sides mean it is isosceles. Exercise number 2 talks about two different lengths of a circle. So notice for this one, they don't give you a diagram. So let's just draw a circle here. Circle O. Whenever it says circle O, O is the center. So it says A and B are located on the circle. So here's point A somewhere on the circle, and here's point B somewhere on the circle. I know that OA and OB are congruent because they're both radii. It tells us that OA is 2x plus 19, and says determine the length of OA if the chord AOB is 37 degrees. So AOB is 37, sorry, not degrees. So this is actually saying that OAB is on its own chord, meaning that this is the diameter. So because A and B are located on the circle, they could be anywhere like I initially drew, but because it says AOB is 37, I know that creates a straight line. So I know that OAB is 37, so that means 2 times the radius is equal to the diameter. If I distribute and solve, I get 4x equals -1, or x equals -1/4. The x value can be negative, but if I plug it back in, I shouldn't get a negative length of a segment. The next type of terminology we have to look at in circles is the types of arcs that we have in a circle. Alright, so in all circles we have arcs, and each arc is measured in a different way because of how long the arc is compared to the angle that opens it up. So what is an actual arc of a circle? An arc of a circle is a distance along the circumference. And this can be measured in degrees, radians, which we'll find out about later, or as a distance, meaning it can be inches, feet, miles, etc. So for example, this would be called arc AC. When we make an arc, we put a little like arc above the two letters. Now within arcs, there are two types of arcs: minor arcs and major arcs. Minor arcs are arcs that represent less than half the circle. So I'll just use the same example again here. Arc AC would be considered a minor arc. It's definitely less than half of the circle. If you were to make the diameter, you could see that it's less than the distance back to the diameter. A major arc, you could kind of assume, is an arc that represents more than half the circle. So if I was to make an arc start here and go all the way around to here, I could even use a third letter to show it and say arc ABC. Notice, again, that would be way more than half the circle. So one of the first things we have to be able to do with arcs is be able to identify the type of arc that we have. They're usually pretty straightforward. So let's take a look at this next exercise here. So it tells us to name the major and minor arcs with endpoints of A and D. So if I just look at A to D here, that is definitely less than half of the circle. So I can say AD is a minor arc. Then I can have a major arc start at A and go all the way around to D. This would be called a major arc. And I would name that A, B, C, D. And I would name this minor arc just A, D. Now that we understand how to kind of look for them, let's look at major and minor arcs that have endpoints of A, B. So I could just say AB, that's a minor arc. All right, so if you follow your circle from A to B, that's less than half. Then if I go from A to D to C to B, that would be a major arc. Then if we look at arc BCD, so I'll use that for green here, so we'll go from B to C to D. Notice that creates a semicircle. All right, so arc BCD is a semicircle. Now, if all circles are 360 and arc BCD is half of that, that means this arc is representative of 180 degrees of the circle. We'll see that in future lessons. Okay, so arcs are important to us because they allow us to determine really essentially where we are. So how much of the circle are we representing? So how big is my sector? And there are types of angles that we'll be able to look at within this circle. Two of them are inscribed and central angles. In this lesson, we're only going to look at central angles. Inscribed is for tomorrow's lesson. So let's first start talking about what is a central angle. And we actually mentioned this in a previous chapter, so this is why this should be good for you to do on your own here. So a central angle is an angle constructed by two radii. Any central angle is equal to the intercepted arc. So if I was to make a central angle here, AOB, I can say, whoa, I don't know what that is. Okay, so I can say angle AOB is equal to arc AB. This arc around the outside. So the crust of the pizza is equal to the arc here. An inscribed angle is an angle constructed by two chords, even a diameter. And we can say the inscribed angle is equal to half the intercepted arc. And an inscribed angle will look something like this. So I can say angle ABC is equal to half of arc AC. But again, like I said, we'll learn more about this in lesson 4. So, central and inscribed. So, let's take a look at this next problem. So this next problem is giving us some angles, it's giving us a bunch of arcs everywhere, and it's asking us to determine each measurement using what we just learned. So the first thing it tells us that angle EBC is 65 degrees. So right away, I see that ABE, that's a diameter, but it's also a straight line. So if I do 180 minus 65, I'm going to get 125 degrees. So that means that angle ABC, actually, I'm sorry, 115 degrees. So angle ABC is 115 degrees. Now, the other thing that I know is that these are all radii. Now, that tells me that triangle EBC is isosceles. Meaning these two base angles at E and C are equal to each other. So if I do 180 minus 65, I get 115. Well, if I divide 115 by 2, I get 57.5. So that means this angle is 57.5 degrees. I can do the same thing to find angle BAC, because I also know that triangle ABC is isosceles. So if I take 180 and minus 115, I get 65, and if I divide 65 by 2, I get these two little angles as 32.5. So I can say angle ABC, or BAC, is 32.5 degrees. Angle ACE, it would be the sum of these two. So if I was to take these two together, that would be ACE. So if I was to do 32.5 plus 57.5, I wind up getting 90 degrees. Well, that's actually a special angle, right? We'll talk a lot more about why that's 90 degrees in a future lesson, but one of the reasons why is because of this diameter, ABE. The next thing it asks us to find is angle ECB. So from E to C to B, we already found that one, so we could just label it. Then let's look at arcs. Arc AC. So arc AC is here. Notice it's created or intercepted by this angle. So since that is a central angle, since it's created by two radii, I know that AC as an arc is 115 degrees. I do the same thing with CE. So CE is an arc that's created here, also a central angle. So I see that this is 65 degrees. Oh, that's too yellow. You're not going to be able to see that. 65 degrees. And then arc AD. If we look at arc AD, AD is coming from here to here. That's not necessarily coming from any angle, but I already know a little bit about this. So I already know that this arc AC is 115. I know this arc CE is 65. And I should be able to figure out what AD is. So one of the ways that we have to be able to figure out what AD is using inscribed angles, and we're not quite ready to use that yet. So let's actually skip part F till tomorrow. So let's look back at that tomorrow. And then we have our homework. So this is what I would like for you to try tonight on your own. Hopefully this video helps.